Good day everyone. Today we're going to demonstrate an Internet of Things application monitoring a temperature and humidity from anywhere by following the 7 or 8 steps shown here. So first we're going to introduce the hardware components that we'll be using with the circuit diagram. We need to make sure that the PC recognizes the hardware, and if not, I'll give you some hints about how you troubleshoot the recognition process. Then we're going to create a channel on Thingspeak, and then we will load the program and then check our data. And if you want those on your mobile phone as well, we will show you how you download the Thingview on your mobile, and then as well you monitor the data as similar fashion to the Thingspeak platform. The hardware we are using today is the D1 Mini Pro. Mainly it has a ceramic antenna. This is the ESP8266 chip. The ESP8266 is a complete and self-contained Wi-Fi network capable chip. It integrates antenna switches, power amplifiers, low noise receive amplifiers, filters, power management, you name it. Besides the Wi-Fi capability of this chip, it also integrates an enhanced version of a 32-bit processor, and it has an on-chip static random access memory as well. This chip is the WinBond. It's a 128 megabit serial flash memory. It provides storage solution to the limited space system here. For this specific model, the D1 Mini, this one is equipped with the CH9102, a USB bus converter chip. It converts the USB to the serial UART. This is the Universal Asynchronous Receiver Transmitter interface. So it's important you download the proper driver for this chip so that your PC recognizes the module. Be aware that each module is equipped with a different USB bus chip, so make sure that you know the number and you download the appropriate driver for it. Now we'll move on to the DHT22. This is a temperature humidity sensor. This is a low power sensor. Its operating voltage range can vary between 3.3 volts to 5 volts, making it suitable for battery powered projects. Inside the DHT22 is the negative thermal coefficient thermistor in it. It has only 3 pins. You have the plus voltage supply, the ground, and you have a data pin. So we will be communicating with the microcontroller via the pin shown here in the middle. This is a single bus communication protocol. So the data is 40-bit long. The first 8-bit is for the integral relative humidity, and then followed by another 8-bit for a decimal relative humidity data. Then the third batch of 8 bits is for the integral temperature, followed by another 8-bit for the decimal temperature data, and then the last 8-bit is the checksum. So if the data transmission is right, the checksum should be the summation of the previous 8-bit batches. You don't need to worry about those details, because we will be using a library that will sort this out for us. We only need just simply ask to read the temperature and humidity, as you will see later on in the Arduino code. You need to check the data sheet. The DHT22 already have a decoupling capacitor in the back, and also has a pull-up resistor. So all what I need to do now is simply connect the pins straight onto the microcontroller. So the plus will go to the +5 here. The ground will go here, and for simplicity we'll connect the data line to D4. Okay, before you connect the hardware to your PC, first you need to visit the website where you can download the driver. Now, based on the module you are using, in my case this is the D1 Mini, so the drivers are somewhere here, the WCH.CN, and based on the USB to serial chip number, then you have to choose the right driver and install it. If you have installed your driver successfully, if you go to the device manager, then after you connect your hardware using the micro USB, it will be recognized straight away. To double check this, you can go to your device manager in your PC and check before you connect and after you connect the hardware whether you can see clearly the USB serial chip name with the COM port you are connecting this to your PC. If this is your case, that means you have a successful connection. However, if you get a yellow exclamation mark on this, then you have to troubleshoot your connection. My first advice to you first, check your cable. Some cables are not data cables, they only transmit power. And cables that are designed to transmit just power between your hardware and your PC is not going to work. Make sure your cable transmits data as well. Now the second possibility is that the driver you installed does not currently support your USB to serial chip. So driver you installed is not compatible. Sometimes a restart of your PC will make it work, and sometimes uninstalling the driver could solve the problem. So by uninstalling the driver and then reinstalling it could do the job. So hopefully this will sort out your problem. Now let's assume you have connected this successfully to your PC. There are two major differences to bear in mind when running the DHT22 sensor on an Arduino as compared to the D1 Mini Pro, which is based on the ESP8266 Wi-Fi chip. The primary difference is that the standard pin numbers do not refer to the pin numbers on the D1 Mini. So the Arduino pin numbers, they do not refer to the same pin numbers on the D1 Mini. So if you're using pin number 1, make sure that you use a D1 instead. The second and the more problematic issue is that the standard library that we used before in Arduino will not work with the D1 Mini Pro. And that's why we will be using a different DHT22 library. And then the credit will go to the guys who made the library, and that will be commented in the code. In the code that we will be using, we will refer back to the guys who made the library to make this DHT22 sensor work with the D1 Mini Pro or D1 Mini versions. So now we need to create the channel in the Thingspeak cloud platform. Now before we arrive at this page, first you need to either sign in or create a new account. You can do this for free. If you don't have an account with Thingspeak, you need to create one. So you have to click on the create an account option. There you will be prompted to enter your email, your first name, your last name, your location, and simply that's it. And then you will be sent an email, and then you have to confirm your email. And once you do this, then you have to create your password, log into your account, and then once you log into your account, you can choose your personal or as a student or as an instructor and so on, and then you simply click on the channels, and now you are on the same page as here. So we will click on the new channel. This is it. So all what you need to do now is simply save the channels. Zooming out a little bit, you should be able to see your temperature versus time and humidity versus time. All what we need at the moment is to grab the application programming interface key. So if you click on the API key, you have the write API key and you have the read API key. Now, since we are going to send the data to Thingspeak, that means we are going to write it. So we need this key, copy it, and then we will paste it in our Arduino code. In addition, this is the format that we will be maintaining in the D1 Mini Pro Arduino code in order to write for the channel here. So if you're wondering later in the code where the details came from, when we want to write the temperature and humidity on the channel, then this is where it comes from. This is the format that we need to follow. This is the code that you will find in the link below. In the API key, paste the application programming interface number that you copied earlier. Make sure that you write your Wi-Fi, network name, and the password. The code is well commented on, so you make sure you read through the comments in order to understand what the code is doing. Mainly, we are setting the baud rate, we are setting up the DHT22 sensor and allocating the data, the single bus communication data at D4, digital pin number 4. And this is the procedure to connect to the Wi-Fi. In the loop, we are reading the humidity, we are reading the temperature, and making sure that the numbers are valid. And then we simply connect to the Thingspeak using the format I showed you earlier in the Thingspeak write feed format. And simply after that, we are displaying the temperature and the humidity. Now we will wait 30 seconds to allow for Thingspeak to update. Of course, this can work in less time, but I'm avoiding clogging my data. Now for the free license, you are allowed around 8,000 messages per day, and the time limit is 15 seconds between each message. Here in my case, I have put 30 seconds first to not to exceed my yearly allowed maximum number of messages, but also just to allow for any delays along the network and so on. Now let's connect the D1 Mini Pro. Okay. Making sure that the port is number is correct. So it's COM8, and making sure that the D1 Mini Pro is chosen as a board. Now we will upload the program. Still compiling. Done compiling, now it's uploading. Okay, done uploading. Checking the serial monitor. As you can see, this is already sending the temperature and humidity. The temperature is 17 degrees Celsius, humidity 64.7, and the data has been sent to Thingspeak. And now we are waiting for 30 seconds before we send the other batch. Now let's go to the Thingspeak and see if this has been updated. This is the Thingspeak. Go to the private view. We need to refresh. Right, I think I have copied the wrong one. I'm wondering why the letter Y was there. So, okay, so we will upload the code again with the updated application programming interface key. We had a letter Y here, which was perhaps from the previous key, which was not deleted properly. Okay, so the code is uploaded. Now we will turn on the serial monitor. It says Wi-Fi connected. Failed to read from the sensor. As I have a dodgy connection here, just gonna make sure it is inserted properly. Okay, so looks like it's doing its job now. Now it's sending the temperature and humidity. Let's wait for another batch. Then we will go over to check the Thingspeak website to see if it's updated. Okay. Now this is the second batch been sent. One is 16.9 Celsius, the other one is 17.4. I'm holding the D1 Mini by my hand because the micro USB is a bit loose, so I'm just holding it, forcing it to stay in. So that's why perhaps the temperature has increased, since the temperature sensor is just laying around. We'll wait for another batch and then we will go to the Thingspeak platform to see if they are updated. Here we go, that's a third batch. Okay, so this is the Thingspeak platform. Here we go. So these are one of the previous updates that when we were attempting to run the code while the serial monitor was off. Okay, so these are the last perhaps is being updated, and the last entry is less than a minute ago. Even though we have just sent around 1, 2, 3, 4 from this run, we had already a couple of from a previous runs. So the last entry is less than a minute ago. Just wait a little bit. Here we go. If you scroll to the last number, it says the temperature is 17. It has a date stamp on it and time. The humidity here is 64. The humidity here is 64.1. So if I go back to my serial monitor, so it was 17 and 64.1. Now a new batch is sent, 16.9 and 64.5. Let's have a look. This is the 16.9 and this is the 64.5. You can see it's updating in real time. So now let's find a way to get those data on the phone. Okay, so this has been running now for around half an hour. in terms of data. If you go to the Play Store on your mobile phone and download the Thingview. Okay, after downloading the Thingview app, in the lower right hand corner, we're going to paste here the read application programming interface key, not the right one, because we are trying to get the information into our app. Now it's confirming to us that the channel is the DHT22/1 room 1. This is the description for our channel, which we have already inserted. We first created the account, and the fields are the temperature and the humidity. So we click on done, and here we go. That's the channel. You simply need to press on this, and this is our temperature and humidity live. It will be fun now if you just go away from the local area network and check this remotely to see whether we still can read the temperature and humidity of this room. Okay, so away from the local area network, this is the value that was recorded earlier. So if I press on refresh, that's the temperature 1. So you can see that the last updated is at 6 o'clock or 8, and this is the clock 6:08. Going back to the temperature and humidity, this is the humidity. If we put refresh, here we go. So what we are doing at the moment, we are measuring the temperature and the humidity in real time, away from your area local network, anywhere in the world. Hello, Cookie. Hello, Jackson. This is Jackson.